Statistics is the backbone of artificial intelligence and machine learning. Without it, models are just guesses. With it, they become powerful tools that can learn, predict, and make decisions. If you're preparing for interviews at top MNCs like Oracle, Google, Microsoft, or Amazon, you'll face tough statistics questions. That's why in this video, I've compiled the top 100 statistics interview questions and answers for AI, covering everything from the basics to advanced topics like hypothesis testing, regression, and Bayesian inference. By the end of this video, you'll be fully prepared to tackle any statistics question with confidence. Let's get started. What is statistics and why is it important in AI? Statistics is the science of collecting, analyzing, and interpreting data. In AI, it forms the foundation for building models, validating results, and making data-driven decisions. Statistical methods help in understanding data distributions, estimating model parameters, and testing whether results are significant or due to chance. Without statistics, AI systems cannot measure reliability or uncertainty. What is the difference between descriptive and inferential statistics? Descriptive statistics summarize and present data using measures like mean, median, standard deviation, or visualizations. Inferential statistics use samples to make conclusions or predictions about a population through hypothesis testing, confidence intervals, or regression. In AI, descriptive stats help explore data sets, while inferential stats validate model performance. What are mean, median, and mode? When would you prefer median over mean? Mean, the arithmetic average of values. Median, the middle value when data is sorted. Mode, the most frequent value. Median is preferred when data is skewed or has outliers, as it is more robust. For example, in analyzing household incomes, the median better represents the central tendency than the mean. What is variance and standard deviation? Why do they matter? Variance measures the average squared deviation from the mean, while standard deviation is its square root, expressed in the same units as the data. They indicate how spread out data points are. In AI, they are critical in loss functions, feature scaling, and probabilistic modeling. What is the difference between population and sample? A population includes all elements of interest, while a sample is a subset used for analysis. Since analyzing entire populations is impractical, samples are taken to make inferences. In AI, training data is a sample of all possible data the model may encounter. What is the difference between a parameter and a statistic? A parameter is a numerical value describing a population, like true mean, while a statistic is calculated from a sample, like sample mean. In AI, model weights are parameters, while metrics like accuracy on a dataset are statistics. What are range, quartiles, and interquartile range IQR? Range, difference between maximum and minimum values. Quartiles, values that divide data into 4 equal parts. IQR, difference between the 75th, Q3, and 25th, Q1 in percentiles, showing spread of the middle 50%. In AI, IQR is used to detect outliers in data preprocessing. What is skewness and why does it matter? Skewness measures asymmetry of a distribution. Right skew, long right tail, example is income. Left skew, long left tail. It matters because skewed data may bias model assumptions. Transformations, example is log, can correct skewness for better model performance. What is kurtosis? Kurtosis measures the tailedness of a distribution. High kurtosis means heavy tails and more extreme outliers. Low kurtosis means lighter tails. In AI, knowing kurtosis helps choose robust algorithms when outliers are present. What is the central limit theorem, CLT? The CLT states that the sampling distribution of the mean approaches a normal distribution as sample size increases, regardless of population distribution. This is crucial in AI for confidence intervals, hypothesis testing, and A/B experiments. What is the law of large numbers, LLN? LLN states that as the sample size grows, the sample mean converges to the true population mean. In AI, this ensures that with enough data, model performance metrics stabilize and reflect true behavior. What is the difference between correlation and causation? Correlation shows association between two variables, while causation indicates one variable directly influences another. AI models often capture correlations, but decisions like policymaking require causal understanding to avoid misleading conclusions. What is the difference between covariance and correlation? Covariance measures joint variability of two variables, scale dependent. Correlation, standardized measure, -1 to +1, that shows strength and direction of a relationship. Correlation is preferred when comparing across data sets with different scales. What is sampling and why is it necessary in AI? Sampling selects a subset of data from a population for analysis. It is necessary to reduce computational cost, speed up training, and enable valid inference without analyzing all data. In AI, stratified sampling ensures balanced class representation. What are the types of sampling methods? Simple random sampling. Each element has equal chance. Stratified sampling. Data divided into strata and samples taken proportionally. Cluster sampling. Groups, clusters, are randomly selected. Systematic sampling. Every KTH element is chosen. In AI, stratified sampling is commonly used for imbalanced datasets. What are degrees of freedom in statistics? Degrees of freedom (DOF) represent the number of independent values that can vary in an analysis after fixing certain constraints. They are important in tests like t-test, chi-square, and ANOVA to correctly interpret significance. What is an outlier? How do you detect it? An outlier is a data point that deviates significantly from others. Detection methods include IQR rule, Q1-1.5, IQR, Q3 plus 1.5, IQR. Z-score, greater than 3 or less than -3. Visualization, box plots, scatter plots. In AI, outliers can distort model training and must be handled carefully. What is missing data and how do you handle it? Missing data occurs when values are absent in a dataset. Handling methods: deletion, if small percent missing. Simple imputation, mean, median, mode. Advanced imputation, like KNN, MICE, using algorithms that handle missing values, example is XGBoost. What is the difference between normalization and standardization? Normalization rescales values to a fixed range, usually 0 to 1. Standardization transforms data to mean 0 and standard deviation 1. In AI, normalization is useful for neural nets, while standardization benefits models like SVM and logistic regression. What is bias in statistical estimation? Bias is the difference between the expected value of an estimator and the true parameter. A biased estimator systematically over or underestimates values. In AI, bias variance trade-off balances low bias with manageable variance for better model generalization. What is probability and how is it applied in AI? Probability is the measure of the likelihood of an event occurring, ranging from 0 to 1. In AI, probability underlies predictive models, uncertainty quantification, and decision-making. For example, Naive Bayes uses probability to classify emails as spam or not. What is conditional probability? Give an example. Conditional probability is the probability of an event A given that event B has occurred, written as P of A given B. In AI, it's used in Bayesian networks. Example: the probability of a user clicking an ad A given they are in a specific age group B. What is Bayes' theorem and why is it important? Bayes' theorem relates prior knowledge with new evidence. P of A given B equals P of B given A times P of A by P of B. It's important in AI for updating beliefs, probabilistic reasoning, and models like naive Bayes, Bayesian networks, and uncertainty estimation in deep learning. What are prior, likelihood, and posterior in Bayesian statistics? Prior: initial belief about a parameter before data, P of A. Likelihood: probability of data given parameter, P of B given A. Posterior: updated belief after seeing data, P of A given B. In AI, this framework enables adaptive learning and Bayesian inference. What is independence versus dependence in probability? Two events are independent if the occurrence of one does not affect the probability of the other. That is, P of A intersection B equals P of A times P of B. If not, they're dependent. In AI, independence assumptions, like in naive Bayes, simplify computations but may be unrealistic. What is the difference between discrete and continuous random variables? Discrete takes finite or countable values. Example, it's on number of clicks. Continuous takes infinite values within a range. Examples is height, time. In AI, classification often involves discrete variables, while regression deals with continuous ones. What is a probability distribution? A probability distribution describes how probabilities are assigned to possible outcomes of a random variable. In AI, distributions like Gaussian or Bernoulli model uncertainty and data variability in algorithms. What is the difference between PMF and PDF? PMF, probability mass function, used for discrete variables, gives the probability of exact values. PDF, probability density function, used for continuous variables, gives relative likelihood of values where total area under curve equals 1. Example, Bernoulli uses PMF, normal uses PDF. What is Bernoulli distribution? Give an example. Bernoulli distribution models a binary outcome with probability P of success and 1 minus P of failure. In AI, it's used in binary classification tasks like predicting whether a transaction is fraudulent, 1, or not, 0. What is binomial distribution? Binomial distribution models the number of successes in n independent Bernoulli trials with probability P. In AI, it's used to model repeated experiments, such as number of clicks in 10 ad impressions. What is Poisson distribution and where is it used? Poisson distribution models the count of events occurring in a fixed interval of time or space, given an average rate lambda. In AI, it's used for modeling rare events, such as server failures or customer support requests per hour. What is uniform distribution? Uniform distribution assigns equal probability to all outcomes in a given range. In AI, it is used in random initialization of model parameters or random sampling in simulations. What is normal distribution and why is it important in ML? Normal distribution is a bell-shaped symmetric distribution defined by mean, mu, and variance, sigma squared. It is important in ML because many models, examples are linear regression, Gaussian naive Bayes, assume normally distributed errors, and CLT ensures many statistics approximate normality. What is the difference between normal and standard normal distribution? Normal distribution, defined by any mean, mu, and variance, sigma squared. Standard normal distribution, special case with mu equals 0 and sigma equals 1. Z-scores transform normal data into standard normal for easier probability calculations. What is exponential distribution? Exponential distribution models the time between events in a Poisson process. In AI, it is used for survival analysis, queuing models, and reinforcement learning, time until next reward. What are heavy-tailed distributions and why do they matter? Heavy-tailed distributions, like Cauchy-Pareto, assign higher probabilities to extreme values. They matter in AI because real-world data, examples are wealth, internet traffic, often has heavy tails, leading to outliers that standard Gaussian models fail to handle. What is multinomial distribution? Multinomial distribution generalizes the binomial to outcomes with more than 2 categories. In AI, it models word counts in NLP tasks like topic modeling or document classification. What is students' T distribution? Students' T distribution is similar to normal, but with heavier tails, controlled by degrees of freedom. It is used for small sample inference, such as estimating means when variance is unknown. What is chi-square distribution? Chi-square distribution is the sum of squared standard normal variables. It's used in hypothesis testing, examples are independence tests, goodness of fit, and in building confidence intervals for variance. What is F distribution and where is it used? F distribution is the ratio of 2 scaled chi-square variables. It is used in ANOVA to compare variances across groups and in regression analysis for testing model significance. What is hypothesis testing? Hypothesis testing is a statistical method to decide whether there is enough evidence in a sample to infer that a condition holds in the population. In AI, it validates model improvements. Examples are comparing a new algorithm's accuracy with a baseline. What is the difference between null and alternative hypothesis? Null hypothesis, H0, assumes no effect or difference, status quo. Alternative hypothesis, H1, assumes there is an effect or difference. In AI, H0 may state that a new model performs the same as the old one, while H1 states that the new model improves performance. What is a p-value? A p-value is the probability of obtaining results as extreme as those observed, assuming the null hypothesis is true. A small p-value less than 0.05 indicates evidence against H0. In AI, it's used to judge if performance improvements are statistically significant. What are confidence intervals? A confidence interval is a range of values within which the true population parameter likely lies, with a given confidence level. Example is 95%. In AI, confidence intervals around metrics like accuracy or AUC show the reliability of results. What is statistical power? Statistical power is the probability of correctly rejecting the null hypothesis when the alternative is true. High power reduces the risk of missing real effects. In AI, it ensures A/B tests detect true performance improvements. What are type 1 and type 2 errors? Type 1 error, false positive, rejecting H0 when it's true. Type 2 error, false negative, failing to reject H0 when it's false. In AI, a type 1 error might wrongly claim a new model is better, while a type 2 error might overlook a truly better model. What is significance level, alpha? The significance level is the probability threshold, commonly 0.05, for rejecting H0. It represents the risk of making a type 1 error. Lower alpha makes tests stricter, but reduces false positives. What is a one-tailed versus two-tailed test? One-tailed test, tests for effect in one direction only. Two-tailed test, tests for effect in both directions. In AI, use a one-tailed test if you only care whether a new model is better. In two-tailed, if you care whether it is either better or worse. What is a z-test? When is it used? A z-test checks whether sample means differ significantly from a population mean or another sample mean using standard normal distribution. It's used when population variance is known and sample size is large greater than 30. What is a t-test? When is it used? A t-test compares means using the t-distribution, suitable for small samples or when variance is unknown. In AI, a t-test can compare model performance across two different datasets. What is a chi-square test? The chi-square test measures how observed categorical data compares with expected frequencies. It's widely used in feature independence tests, such as checking if a categorical feature is independent of the target in AI. What is ANOVA? Analysis of variance? ANOVA tests whether means of multiple groups are equal by comparing within group and between group variance. In AI, it helps compare the performance of several models or hyperparameter settings at once. What is the difference between one-way and two-way ANOVA? One-way ANOVA compares means across groups based on one factor. Two-way ANOVA considers two factors and their interaction. In AI, two-way ANOVA may evaluate both algorithm type and dataset size effects on performance. What is MANOVA, multivariate ANOVA? MANOVA extends ANOVA to multiple dependent variables. Instead of testing one outcome, example is accuracy, it can simultaneously test multiple metrics. Example are accuracy and F1 score. What is the Kruskal-Wallis test? The Kruskal-Wallis test is a non-parametric alternative to ANOVA that compares medians across groups without assuming normal distribution. It's useful in AI when data is skewed or ordinal. What is the Wilcoxon signed rank test? The Wilcoxon signed rank test is a non-parametric test for comparing paired samples. In AI, it can compare two algorithms' performance across the same datasets without assuming normality. What is the Kolmogorov-Smirnov test? The KS test checks whether a sample comes from a specific distribution or compares two distributions. In AI, it can test if predicted probabilities follow the expected distribution. What is A/B testing and why is it important? A/B testing compares two versions, A and B, of a system to see which performs better. In AI, it's critical for validating model improvements in production, such as testing if a new recommender increases user engagement. What is bootstrapping in statistics? Bootstrapping is a resampling technique that draws repeated samples with replacement from the dataset to estimate variability. In AI, it's used for model validation, confidence intervals, and ensemble methods like bagging. What is permutation testing? Permutation testing evaluates the significance of a result by randomly shuffling labels and recalculating test statistics. In AI, it helps assess if model accuracy is better than chance without distributional assumptions. What is regression analysis? Regression analysis is a statistical technique for modeling the relationship between a dependent variable and one or more independent variables. In AI, regression is used for prediction tasks such as sales forecasting, price estimation, or demand prediction. What is linear regression? Linear regression models the relationship between variables as a straight line, where y equals beta 0 plus beta 1 x plus epsilon. It assumes a linear relationship between input features and output. In AI, it's a baseline model for prediction tasks and is also used to interpret feature importance. What assumptions does linear regression make? Linearity between features and target, independence of errors, homoscedasticity, constant error variance, no multicollinearity among predictors, errors normally distributed. These assumptions ensure valid inference and reliable predictions. What is logistic regression? Logistic regression models binary outcomes using the logistic sigmoid function. Instead of predicting values, it predicts probabilities of belonging to a class. It's widely used in AI for classification tasks like spam detection or fraud prediction. What is the odds ratio in logistic regression? The odds ratio quantifies how a one-unit change in a feature affects the odds of the outcome. An odds ratio greater than 1 increases the likelihood of the event, while less than 1 decreases it. It's useful for interpreting feature impact and classification. What are residuals in regression? Residuals are the differences between observed values and predicted values. Analyzing residuals helps check model assumptions, detect outliers, and evaluate model fit. What is R-squared coefficient of determination? R-squared measures the proportion of variance in the dependent variable explained by the model. Ranging from 0 to 1, higher values indicate better fit. In AI, it's used as a performance metric for regression models. What is adjusted R-squared? Adjusted R-squared modifies R-squared by accounting for the number of predictors. It penalizes adding irrelevant variables, making it a better measure for comparing models with different numbers of features. What is multicollinearity? Multicollinearity occurs when independent variables are highly correlated, making it difficult to estimate their individual effects. This inflates variance of coefficients and reduces model interpretability. How do you detect multicollinearity? Methods include variance inflation factor, VIF, greater than 10, high pairwise correlation among predictors, instability in regression coefficients. Detecting and resolving it improves model reliability. What is heteroscedasticity? Heteroscedasticity occurs when the variance of errors is not constant across values of predictors. It violates regression assumptions and leads to inefficient estimates. Plotting residuals versus fitted values helps detect it. What is homoscedasticity? Homoscedasticity means errors have constant variance across all predictor values. It's an important assumption in regression, ensuring valid standard errors and significance tests. What is correlation coefficient? Pearson's R. Pearson's correlation coefficient measures the linear relationship between two variables, ranging from -1 to +1. In AI, it's used for feature selection and exploratory data analysis. What is Spearman's rank correlation? Spearman's correlation measures monotonic relationships using rank order data. Unlike Pearson's, it does not assume linearity or normality, making it useful for ordinal or skewed data. What is Kendall's tau correlation? Kendall's tau measures ordinal association by comparing concordant and discordant pairs of observations. It's more robust to outliers than Pearson's and useful in non-parametric statistics. What is autocorrelation? Autocorrelation measures the correlation of a variable with itself over successive time intervals. In AI, it's critical in time series analysis for detecting seasonality and lag effects. What is partial correlation? Partial correlation measures the relationship between two variables while controlling for the effect of others. In AI, it helps identify true relationships after removing confounding variables. What is stepwise regression? Stepwise regression is an automated feature selection method that adds or removes predictors based on statistical significance, p-values, AIC, BIC. It helps build simpler models but risks overfitting. What is regularization in regression, L1, L2? Regularization adds penalty terms to the regression cost function to prevent overfitting. L1, lasso, encourages sparsity by shrinking some coefficients to zero. L2, ridge, shrinks coefficients but keeps all predictors. Both improve generalization in AI models. What is the difference between ridge and lasso regression? Ridge regression, EL2, shrinks coefficients but never eliminates variables. Best for multicollinearity. Lasso regression, L1, can reduce some coefficients to zero, performing variable selection. Best for sparse models. What is maximum likelihood estimation, MLE? MLE is a method of estimating parameters by finding values that maximize the likelihood of observing the given data. In AI, it's widely used in logistic regression, HMMS, and neural network training. What is Bayesian inference? Bayesian inference updates prior beliefs with new data using Bayes' theorem. It provides posterior probabilities instead of single estimates, making it useful for uncertainty quantification in NA models. What is maximum a posteriori map estimation? MAP estimation is similar to MLE, but incorporates a prior distribution. It finds the parameter value that maximizes the posterior probability. In AI, MAP is used in Bayesian networks and NLP models. What is Markov chain Monte Carlo MCMC? MCMC is a class of algorithms for sampling from complex probability distributions using Markov chains. In AI, it's applied in Bayesian deep learning, probabilistic graphical models, and reinforcement learning. What is Gibbs sampling? Gibbs sampling is an MCMC method where variables are sampled iteratively from their conditional distributions. It's commonly used in topic modeling, e.g., latent Dirichlet allocation. What is the expectation maximization EM algorithm? EM is an iterative algorithm for estimating parameters in models with latent variables. It alternates between estimating missing data, E step, and maximizing likelihood, M step. In AI, it's used in Gaussian mixture models and clustering. What are latent variable models? Latent variable models include hidden unobserved variables that explain observed data. Examples include factor analysis, topic models, and hidden Markov models. In AI, they capture hidden structure in data. What is principal component analysis, PCA? PCA is a dimensionality reduction technique that transforms correlated features into uncorrelated principal components. In AI, PCA reduces feature space, speeds up training, and removes noise. What is factor analysis? Factor analysis models observe variables as influenced by a few latent factors, plus error terms. It's used for uncovering hidden structures in data, such as personality traits in psychology or user behavior in AI. What is singular value decomposition, SVD? SVD decomposes a matrix into three matrices. A equals U SVT. It's used in dimensionality reduction, noise reduction, and recommendation systems, e.g., collaborative filtering in Netflix. What is multivariate analysis? Multivariate analysis involves analyzing multiple variables simultaneously to understand their relationships. In AI, techniques like MANOVA, canonical correlation, and clustering are used for high-dimensional data analysis. What is time series analysis in statistics? Time series analysis studies sequential data over time to identify trends, seasonality, and cycles. In AI, it's used in stock price prediction, weather forecasting, and anomaly detection. What is stationarity in time series? Stationarity means statistical properties mean variance, autocorrelation, remain constant over time. Many AI time series models, example is ARIMA, require stationarity for accurate predictions. What is the ARIMA model in statistics? ARIMA, autoregressive integrated moving average, combines autoregression, differencing, and moving averages to model time series data. It's used in AI for forecasting sales, demand, and resource usage. What is cross-validation from a statistical perspective? Cross-validation partitions data into training and validation sets to assess model performance. Statistically, it reduces bias and variance in error estimates. In AI, k-fold cross-validation is standard for model evaluation. What is statistical significance in AI models? Statistical significance tests whether an observed effect, examples are accuracy improvement, is likely due to chance. In AI, it ensures that performance gains are genuine and not random fluctuations. What is false discovery rate, FDR? FDR is the expected proportion of false positives among rejected hypotheses. It's crucial when testing multiple features or models, helping avoid overestimating effects. What is the difference between confidence bands and prediction intervals? Confidence bands range for the mean prediction across samples. Prediction intervals range for individual future observations. In AI, prediction intervals are more useful for uncertainty in forecasts. How does statistics help in feature selection? Statistics identifies relevant features using correlation tests, chi-square, ANOVA, and mutual information. This reduces dimensionality, improves efficiency, and avoids overfitting in AI models. How does statistics support AI model evaluation and fairness? Statistics ensures reliable evaluation by measuring accuracy, precision, recall, confidence intervals, and hypothesis testing. It also supports fairness by detecting bias through statistical parity, disparate impact, or hypothesis-driven subgroup analysis. You just learned 100 of the most important statistics questions for AI interviews. Remember, statistics isn't just theory, it's what powers AI models to make reliable, data-driven decisions. If you found this video useful, make sure to like, share, and subscribe for more AI and machine learning interview prep. And here's a tip. Go back and practice these answers in your own words. That's how you'll master them. Thanks for watching, and I'll see you in the next video, where we dive even deeper into the world of AI